That's the plan, is finish learning how to do elimination, do some practice, and then hopefully at the end we have some time to do some mixed practice today. So pretty much after this lesson, you're going to know all the skills that you need to know. Now it's just a matter of practicing all of it together. Go ahead. A little bit out of order, but go to page, we're going to start on page 21, then we're actually going to go backwards. It's okay. There's a method to the madness. But while you're turning there, just so you kind of know what's on tap for this week, next class, we are going to take a CFU, kind of over what we've done so far. And you do have a district snapshot that we're going to have to do as well. But that'll be kind of over old stuff. Do what? Yeah, but the snapshot, I don't think has any systems on it. I think it's like older stuff. And it's just to kind of see where you are. It's not something to stress about. The CFU is really more important to me because I want to know where you are with systems. And then you'll just do the snapshot afterwards. And then I think I have a GIM kit or something that we can work on then too. And then at the end of the week, we're going to kind of bring back some of that writing. I know we all loved word problems, but we're going to kind of bring that back and we're going to do writing and solving. So kind of merging it all together. Remember, your test is until the end of next week. It's 2 separate grades. It's your last 2 grades. So we got lots of time to kind of put all these puzzle pieces together so we can be ready for that. And then we're getting very close to the end of the semester. 14 more days.
Is our IPR next Monday?
I think they were Friday was the IPR. I think they'll be posted by the end of the week. Okay. But the grade cutoff was Friday. So I've already submitted y'all's.
All right.
So whatever's in the grade book right now is what will be on your IPR.
Okay.
Because we haven't had that other grade yet. So again, we're going to be on page 21 and do this warm-up real quick. And then we're going to, like I said, work our way backwards because, I can't ever go in order. So, problem number 1, it says, what is the value of x? And I want you to work this problem on your own, but I just kind of want to get you started. This is a STAR question. Y'all know we normally get these from the STAR. This is just asking for the x value in the solution. So far I've been saying find the solution. You have to find the x and the y. But this type of question just wants the x. So that means if you find that first, you're done. But if you don't find it first, then you have to go back and solve for it. But here's your system. You got 3x minus 5y equals 22, and y equals negative 5x plus 32. What method should we use? The what?
Substitution.
Y substitution. That's what I would do. But why'd you choose substitution?
They already gave you the y value.
They gave you the y value. So remember, when our key is if they're both in slope-intercept form, we would think graph. Are these both in slope-intercept form? No. If one of our variables is all by itself, it's an x equals or a y equals, that would make me think substitution. That's what I have here. And then if they're both in standard form, that's elimination. That's what we're going to keep practicing on today. So I would do substitution here. Okay, Daniel, where am I going to put my box?
On the 3.
No. Where am I going to put my box around my equation?
Oh,
I got to look at which variable's by itself.
The 5x, right?
Plus the whole thing. I'm going to box that whole thing. What y is equal to. Whatever it says. X equals, box that. Y equals, box that. And then you're going to sub it in for what it's equal to. Miles, what's it equal to?
It's equal to y.
So this is going to go up here. For the y. Okay? All right. So you guys take it from here. This is the subbing that we will do, and then you get to do your solving. Remember, you want to do a checkpoint. Make sure you have all the same letter. And guess what letter we have? What's the variable that we have here? X. So that means we're going to find x first. And then what are we looking for?
X.
So when we find that, we're done. Okay? Work that out. So let's look at this one real quick. So got you kind of started with the substitution because we haven't done that for a few days. And then you distribute. Watch this. This is like distributing a negative 5. So you got to be careful with your negatives. Negative times a negative is a positive. Negative times a positive is a negative. So distribute. Combine like terms. So I combine my two x's to get 28x minus 160 equals 22. Added over the 160. Divided by the 28. I saw Zane put this in his calculator, alpha y equals, because we do that like 99% of the time. but it gave him a fraction. Fractions didn't match our answer choices. So just to review, in case that happens, doesn't mean you did it wrong. It just means you need to look at what that is as a decimal. And to do that, you just do the numerator divided by the denominator. So 13 divided by 2, that gives us the 6.5. And so that's how we can match answer choice C. And again, this question just asks for the X. That's what we found first, so we're done. If it asks for the Y, we would have to keep going. So be very careful, especially if they only ask for one. I think we're going to do that on your test as well. So make sure, you're paying close attention to which one it actually is asking you to do. And then that was just a quick review on substitution. What about the next one?
D.
Which graph has no solution? You said D? I agree. Why?
Because it's parallel.
Because they're parallel. So how many solutions does A have?
1.
1. C?
1.
1. B?
1.
It will have 1. Now you can't see it, but if you were to follow those lines, you would see that it has one solution. And these two lines, these are parallel lines. Parallel lines, and those have no solution. Okay? So this was a nice review on graphing, a nice review on substitution. Like I said, we're going to go backwards, and we're going to go back to page 20 and do our elimination breakdown. We started on elimination last class, but I thought it might be helpful just to go ahead and kind of write our breakdown, and then we're going to get into some of the little bit more advanced elimination problems. But again, keep in mind, this is usually the preferred method. So give it a chance. We'll do some practice. We'll work on those puzzles, and then hopefully you'll feel really good about all the methods. So go ahead and fill out the 3 types of solutions and a visual example. We've done this like 3 days now. So we need to know what that looks like. So draw a graph as your visual examples and draw it kind of small. And then we're going to put kind of what happens algebraically as well. But there's 3 possible cases for solutions.
Yeah.
That's a... So again, we can have our most common case, which means there's one solution. So graphically, what happens when there's one solution? What do your lines do? They cross. They cross. It doesn't necessarily have to be an X. You could have lines that cross that look, well, I mean, I guess it could be just like a slanted X. But you can have, as long as they cross, that's what makes it be one solution. What kind of lines have no solution? Parallel. We just reviewed that. So that means they never cross. They would have the exact same slope. And then infinite solutions would be 2 lines on top of each other. So I'm going to draw a horizontal line this time. But typically when we graph these, we'll just make them look thicker so you can tell they're the exact same line. So that's what would happen graphically. Algebraically, with a substitution or elimination, if you had one solution, you would end up actually being able to solve for X and solve for Y. So kind of like that problem that we just did, and we'd write it as an order pair. So like you would get X is this, or Y is this. That means there's going to be one solution. There's an answer. With a no solution problem, what kind of statement do you get left with? Remember, this is kind of that weird case where your variables go away, or you're just left with what type of statements? To be no solution. What do you think? Thank you. False statements. False statements would be a no solution. You want to give me an example of a false statement?
5 equals 2.
5 equals 2. That's a no solution. Okay? What about 0 equals negative 10?
Yeah.
That's a no solution. And then if it's an infinite solution, then we would be left with true statements. True statements. What'd you say? 1 equals 1?
Yeah.
Okay. For some reason I wrote 11, so we're going to go with 11 equals 11. Don't know why, but 1 equals 1 works. 2 equals 2 works. What about 0 equals 0?
Yes.
What about x equals x?
Yeah.
Okay, so those are all the difference between the two, and that's what would happen algebraically. So using substitution or elimination, something like that would happen, and you'd be left with a true statement or a false statement. Remember, that's not the most common case, but it can happen. So we want to know when it does, what happens. All right, when should we use elimination? We kind of reviewed this last time. And I think I said it in the warm-up. What's your setup? And if you might want to look back a few pages. We wrote some stuff down. When they're both in standard form. When both equations are in standard form. AKA they are lined up. Okay? X over X, Y over Y, equals over equals, constant over constant. That's kind of the giveaway to use elimination. And there's a lot of times that word problems are set up to use elimination. So it's definitely a good process to know how to do. So your steps. Step number 1, when we're using elimination, the key with this, and this is kind of the difficult step here, is we have to create a zero pair. Do you remember me saying that last class? What a zero pair is? Let's define that. A zero pair is where you have the same coefficient, which a coefficient is what? The number next to the variable. So you need to find a variable, X or Y, doesn't matter which one, that has the same coefficient, so the exact same number. But for them to be a zero pair, what do their signs have to be? If I have a 2x, what's a zero pair for a 2x? What's going to make that add to be 0? Negative 2x. That's a zero pair right there. 2x and negative 2x. Because what is 2 plus negative 2? 0. If I have a negative 10y, Muhammad, negative 10y. What's the zero pair to that? No. Negative 10y, and what's going to add to that to make it 0? What? Oh, you said bless you. Anybody know? If negative 10y, and it's positive 10y. Okay, look at the two numbers. They're the same numbers, but one is positive and one is negative. So they have to have the same coefficient, but they have to have opposite signs. Now, to create that zero pair, you may, and I say may, and I mean you probably, are going to have to multiply one or both equations. And that's what makes this more challenging, is figuring out how do we get the zero pair. Okay, we practiced some ones last time that it was already there, and it was nice and easy. But today is going to be more like, okay, how do we set up this situation to where it is a zero pair? And that involves multiplying the entire equation. And sometimes you have to multiply both. Sometimes you just have to multiply one. So you got to figure out how to do that. All right, so creating the zero pair, that's like the hardest step. It's the most important step. After you have that zero pair, you're going to add the equations. And when you do that, one of your variables is going to eliminate, and then you're going to be able to solve for the first variable. So one thing will be Xing out, eliminate, and then you're going to have a very simple equation. 5x equals 15. And we divided by 5. Divided by 5. This was the problem we did last time. So you're going to get your first variable, and just like with substitution, you're going to plug that in and go find the other variable. So step 3, plug in value of first variable and solve for second variable. Can't spell today. And then step 4, write as an ordered pair. So remember, these algebraic methods, they are a lot. They take quite a bit of time, several steps. But just like substitution, the more you do, the more you get a hang of it, it does get a little bit easier. So it's just about seeing a lot of examples. So we'll work 4 together. Then I think there's 5 in your puzzles that you can work on. And and then hopefully we'll feel like we're in a better place. Yes.
I have a quick question for tomorrow's district snapshot. So do you know like if it's gonna be like old stuff?
All right, here's our flow on elimination. All right, we're going to go backwards again. And this is going to be the last page that we do together. So remember, we kind of did some elimination problems last time. Right here, if you kind of remember the process. We had to create a zero pair on 3 and 4 because we had to multiply our equations by -1. But that's the idea of like, I've got to get, and you have to know what a zero pair is. It has to be the same number in front, one positive, one negative. Now remember, with elimination, you kind of have a lot of freedom, like to decide what do you want to what do you want to eliminate? Do you want to take out the x or do you want to take out the y? Which equation do you want to plug back into? So there's like multiple routes you can take and still get the same solution. But my advice to you is try to take the easiest way. Try to take the easiest route. So you'll see what I mean by that when we jump into some examples. We're actually going to start with number 6. So number 5 is one of those special cases, but we'll do that in a second. So let's look at number 6 right here. Okay, so first thing, is everything lined up? X over x, y over y, equals number. Everything lined up? Yes. So I'm going to put an E for elimination. All right, because it's set up for that. And that's what we're doing today. All right, I'm going to analyze my coefficients. So let's look at my x's. What's my coefficient in the top equation? 1, positive 1x. What's the coefficient here? 4. Those are not the same number. Okay, so let's look at the y's. What's the coefficient on y at the top?
1.
What kind of 1?
Negative.
-1. What's the coefficient on y on the bottom?
-5.
-5. Okay, neither of those are the same. But 1s are not bad to work with because you can turn a 1 into anything by just multiplying 1 by whatever number you want. So at this point, taking out x is going to be just as easy as taking out y. Okay, Emma, I'm going to take out x or y. You take out 1 at a time, okay? All right, Emma says we're going to eliminate x. So I'm going to make a little note right here. We're going to eliminate x. That is what we want to create a zero pair with. So if my bigger number is positive 4x, what's going to be a zero pair with positive 4x? -4. So I have to turn this positive 1 into a -4. Well, since it's a 1, all I have to do is multiply it by what I want it to be. So I'm going to multiply my top equation by -4. I want you to write this. I want you to put parentheses around the top equation like I did. I want you to put a -4 on the outside because that's what I want to turn that 1 into. And 1s are easy to change. And I can do this as long as I distribute the -4 into all 3 terms. So I need to see 3 little rainbows right there. Okay? I want you to write that down on your paper. And I do not have to change the bottom equation at all. Okay? Because I'll have my zero pair set up. So let's go over here. We need to do a rewrite. When I distribute that -4 in, -4 times positive 1x is going to become -4x, like I wanted. -4 times -1y, Miles, what's a negative times a negative? Positive 4y equals, and then I got one more. Don't forget the last guy. -4 times positive 7, -28, very good. And then I didn't need to change the second equation, so I'm just going to write that down exactly as is. And now I have my zero pair right here. So do y'all see that extra work I had to do to create this?
Yeah.
We okay? All right, so then step 2 was to add up the equations. Well, when I add them up, where do my x's go? Away. Eliminate. 0. Goodbye. No more x's. What happens with my y's? 4y plus -5y is -1y. And -28 plus 26 is Okay. And then what do I do with the -1 in front of the y? divide it. And so I'm left with y equals,
1.
no,
2.
2, positive 2.
How did you get negative 28?
We multiplied the top equation. When you multiply to create the zero pair, you have to go all the way through. So I had to multiply negative 4 times 7 to get negative 28 right there. That's really important. Make sure you multiply the whole equation, or else it doesn't stay balanced, and then it's not an equivalent equation anymore. So I got y equals 2. Okay?
Do you have to solve for the whole equation now?
You do. We're finding the whole system here. So again, you got options. Do you want to plug y equals 2 into this top y or this bottom y?
Top.
I would do the top. I think there's less numbers. Does it matter?
No.
No, but we want to try to work smarter, not harder. Okay? So let's plug this in to the top equation. So plug y equals 2 into the top. So the top equation says 1x, and I'm going to continue to put the 1s. I don't have to, but why not? Minus 1. What do we know y is now?
2.
So I put the 2 in, take the y out completely. Goodbye, y. Put in a 2. And that equals 7. Okay? Negative 1 times 2 is what number? Negative 2. Very good. So I have that here. Okay? And then I'm solving. So what do I have to do with that minus 2?
Plus 2.
Add it over. Plus 2 plus 2. And that gives me 1x. Do I need to write the 1?
I'm sorry.
Just do x equals 9.
Just give it, we'll get the...
X equals 9. Okay? And so now that I have them both, how do I write my solution?
9, 2.
Good. X, comma, y, 9, comma, 2. There's your answer. Okay?
Why not the others?
So one thing that I think is kind of cool, technically you can do this on all the problems, but it's really easy in elimination to check. If you get that your solution is 9, comma 2, that means if I go back to my original and I plug in a 9 for x and a 2 for y, I should get 2 true statements. So watch this. So the top equation says x, I got my x value was 9, minus my y value I got was 2. And when I press enter, what should I get if this works, if I did it right? What does it say?
7.
7. Check. Now I got to check the other one. 4 times, what did I get for x?
9.
9. Minus 5 times 2. When I hit enter, what should I get?
26.
And if I do, that means I did it right. So technically you can do this for like all the methods. I think it's quickest to do it with elimination because it's set up that way. But that is like, I mean, if you have no idea what to do on the STAR test, you could always work backwards like that too. Okay? How are we doing? We okay? All right, kind of tricky sometimes to figure out how to set these up. Let's try 5. Let's try 5. Are we lined up? Everything lined up?
Yes.
Do y'all know what I'm looking at when we're lined up? X over X, Y over Y. Okay? All right, let's analyze our variables. We got a 1X and a 2X. Those are not the same number. We have a negative 5Y and a negative 10Y. Those are not the same number. Okay? Remember, I said 1s are easy to manipulate. So my brain would be saying, I'm going to eliminate X. Because one of these coefficients is positive 1. And 1s are easy to make whatever we need them to be. All right? So if this is a 2x down here, what do I need to turn the top one into? What kind of 2x? A negative 2x. So I'm going to put parentheses around this. I'm going to put a negative 2 on the outside. And how many rainbows am I going to draw? 3, because I got to go to all 3 parts. 1, 2, 3. Negative 2 times positive 1x is negative 2 times negative 5y,
Plus
10.
negative 2 times positive 10.
Negative 20.
Do I need to do anything to the second equation?
No.
Copy it down. That's about it. as is. Add them up. Where do my x's go?
Cancel
Bye
out.
bye.
Bye-bye. Eliminate. What happens with my y's?
Eliminate.
Same thing.
They also eliminate. Okay, so what is this telling me?
Oh, it's none.
It's going to be none or it's going to be infinite. So we got it. We're going to have a 0 right here. If they both cancel out, put a 0.
0
Okay.
equals 0. It's infinite.
Now what's happening over here? This is also a
Yep.
0. And this is
Can't do it to the big number.
true. And so that means my answer is
No, so,
Infinite.
infinite. Or what else could you say?
All.
All solutions. So that's one of those special cases. Again, if you turn in your test and you get every single answer is infinite or no solutions, that's going to be a red flag. But if you see it there once, twice, it's probably okay. It's something that can happen. But most of the time, we are going to be able to find one. Okay? So what do we think so far? It's not too bad. It's creating that 0 pair that gets kind of tricky. And the last two are a little bit trickier. Okay? But I think we'll be able to figure them out. We can talk through it.
I know, that's what I
Make 'em
didn't
work.
watch.
Okay?
I showed you that.
All right, let's try 7. We'll do 7 together, and then I'm going to let you guys try 8 on your own. Okay? All right. Are we set up for elimination? Lined up? Yep. Okay. Now let's analyze our variables. Let's look at x. We've got a 5x and a 3x. Those are not the same number. Nope. Let's look at our y's. 4y and negative 9y. Also not the same numbers. Okay? Are there any coefficients of 1s in here? No. Okay, let's look at the x's. The game I kind of play is I look at the smaller number. Can I multiply 3 by a whole number and get to 5?
Yeah.
By a whole number?
No.
No. Okay, what about 4 multiplied by a whole number and get to 9? Okay, so this is honestly about as difficult as negative 9. Thank you. This is about as difficult as it could get when you can't turn one number into the other very easily. We're going to have to multiply both equations here. Okay? So, who haven't I picked on today? Nick, do you want to eliminate the x or do you want to eliminate the y? Eliminate the x. Okay? Those are the smaller two coefficients, so I think that's probably fine to do. Okay? If you want to do eliminate y, could you do it that way? You're just going to be working with bigger numbers. Okay, so we agree we cannot turn a 3 into a 5 by multiplying by a whole number. Therefore, we are going to have to multiply both equations. So I want you to watch what I'm about to do. And this will always work if you can't figure out what to do. You can always do what I'm about to do. Again, I like to write to the side what I'm eliminating. Okay? Ethan, you with me? All right, let's start with the first equation. I'm going to multiply the first equation by, listen to what I'm saying, the coefficient of the variable I'm eliminating of the second. That was a lot of words, okay? So I need to multiply my top equation by this coefficient on the bottom, which is a 3. Okay? And then I'm going to multiply the bottom equation by the coefficient of x in the first equation, which is a 5. Now, here's why I did that. What is 3 times 5? What is 5 times 3? So you can always, it's kind of like a crisscross thing. You can always crisscross here to end up getting the same number, okay? Because multiplication is commutative.
Hold on.
But
There's one more thing.
3 times 5 is 15. 5 times 3 is 15. Both those are positive. What do I need one of them to be?
Negative.
Okay? Heidi, do you want to make the 3 negative or the 5 negative? Okay. Could you make the 5 negative? Sure. Let's take a look at that. Is everyone okay? You okay? Why are we doing both? Because I could not turn a 3 into a 5 by multiplying by a whole number.
What about a decimal?
I prefer just to stick with whole numbers. I think that's easier than dealing with decimals and getting decimals in other places. Doesn't mean you can't do it. I wouldn't. So if you can't, now if you have, Johan, if you had if that was a 3 and a 6, we could turn a 3 into a 6. So I'd be like, oh, I'm just going to multiply it by 2. But it's when you can't turn them into each other that multiplying by both is kind of what you're going to have to do. Which means how many little rainbows are you going to have to draw in this problem?
4.
No.
Oh, 3.
1, 2, 3, 4, 5, 6. This is why this is
So you're gonna multiply 6 times.
6 times. All right, let's do the top one. We got to watch our signs because the top one's negative. Negative 3 times positive 5x is
Negative 15
negative
next.
15x. Negative 3 times positive 4y is
12y.
negative 3 times negative 30. Nick, you writing this down? Is what?
Positive 60.
No,
90.
it'll be 90. Right? 30, 60, 90.
You see what they're doing right now?
This is the most challenging. If you can do this elimination problem, you can do any of them. Okay? This is this step right here. All right, bottom equation. 5 times 3x is positive 15x. There's our 0 pair, like we wanted. 5 times negative 9y is
Negative 45.
5 times negative 18.
-3 times 4.
Y'all got calculators in front of you. It's negative 90. Okay, and now we add.
3 times, right?
Is everyone okay? Did everyone see that I multiplied 6 times? 3 times for each equation, yeah? All right, what happens to my x's when I add them up? They go away. That's what I wanted. One of those should be, oop, I forgot my y right here. No one told me that. All right, with my y's, negative 12 plus negative 45 is, okay. And then 90 plus negative 90 is 0. Now, I do like this problem. Is this going to be a no solution problem?
Yes.
Negative 57y equals 0. There is a variable here.
So it's plus 57.
Not plus, because it's negative 57 times y. This is not a no solution. I don't want you to see a 0 and assume it's a no solution or all solution. It's only that if both of these x out, okay? If there is still a variable left and you can solve for it, like 0 is a number, you can work with that, just like you'd work with any other number. So there is a solution to this problem. And like Braden said, we have to get this negative 57 away from the y, so what are we going to do?
Divided by the number.
Divide. And then if we go in our calculator, 0 divided by anything is just 0. And since there is still a y there, x or y can equal 0. 0 is a number. So there is a solution. So what does that mean we need to do now? Final step.
Find x.
Find x. Okay? Cruz, top equation or bottom equation to find x?
Oh, so we gotta eliminate y now?
We don't have to eliminate. We have to solve for y. What'd you say? Top. Okay, Cruz wants to go to the top. So we're going to plug y equals 0 into the top. And honestly, zeros are a little bit easier to work with. So it's not the worst thing in the world that happens. So the top equation says 5x plus 4 times y. But what is y? What is y?
0.
0 equals negative 30. Sorry, I'm in the other problem now. What's 4 times 0? 5x equals negative 30. What do I do now, Miles?
Divide by 5.
Thank you, Miles. And so x equals, so your solution is
Negative 6.
negative 6, comma, 0. So 0's okay. 0's a number. We can work with that. And now we can go from there. Do you guys want to work together to set up number 8?
Yeah.
It's another one. I don't think it's quite as crazy as 7. But it is one that we're going to have to multiply both equations. So let's at least get started. And then I'll let you kind of take the solving from here. And y'all, if you can do 7 and 8, you can do any elimination problem. 7 and 8 are like level 4. The highest of the highest. Okay? Involving multiplying both of those. So let's look at our x's. 3x and 2x, are those the same?
No.
Is a 2 turned into a 3 by multiplying by a whole number? No. Okay, boo. Let's check the y's. -2 and +5. Are those the same?
No.
Can you turn a -2 into a 5?
Yeah. Wait, no.
No, not by multiplying by a whole number. Okay. So that immediately tells me that I'm going to have to multiply both equations. But I do think there is an easier way out here. What do you notice about both of the x's? They're both what kind of numbers? Positive. What do you notice about the y's?
Both negative. Or, no. One's positive,
One's positive and one's negative. So if they already have the signs right, let's take out the y. Because that means, do I have to change any signs?
No.
No. So do I have to multiply by a negative number?
No.
No. And I think it's easier if you can multiply by a positive. I could have done that on number 7 as well. All right, remember the crisscross thing. I'm taking out y's. So I'm focused on the y's. The top equation, I'm going to multiply by the coefficient on the bottom. What's the bottom coefficient of y? 5. Positive 5. Over here, I'm going to multiply bottom equation by the coefficient, and I don't need to make it negative because they're already opposite signs. I'm going to multiply by the coefficient on the top, which is a 2. Now, just double check. 5 times -2 is? What's 5 times -2? Negative 10. 2 times 5 is? Positive 10. Is that going to be a 0 pair? Yes. So, 1, 2, 3. 1, 2, 3. Take it away. Okay, y'all check up here. Make sure your multiplying is the same as mine.
And then
This is 3.
And then add 'em up.
Y again.
What?
We said Y.
You add them up? Oh, did you get the x
Has
first?
nothing to do with X. You just
Take
write
the x,
down.
plug it back into either this one or this one.
3X.
There's no matter.
Doesn't matter. It's up to you. I would do one of the original ones. I wouldn't do one of the multiplied ones, but
I'll do the all positive.
Yeah, that's right.
So I,
5 times 3 is definitely not 6. Thanks for the shout out. It should be 15. X minus 10y equals 20. Did I do this right? Yeah. Thank you. All right, when I add them up, what is 15 plus 15x plus 4x? 19x.
yeah, 19x equals 38. And then, and then you divide them.
Because you're doing them in your head.
And then you get 2.
I think it's making
I get what equals 2.
X equals 2.
It is very important, you guys, since there are 2 variables that we're solving for, that you stay consistent and you make sure you are writing and don't get confused with your handwriting. Don't have sloppy handwriting and be like, is that an X or a Y? I don't know. That's important, and that's going to make a difference. Okay? I do think the arrows multiplying, drawing all of those, that's just bringing your attention. You have to multiply 3 times. Just multiply right. Even I can't do it, okay, sometimes. So thanks for the help. And then what do I do now? What do I do with my first variable?
You plug it in.
Plug it in. Okay, which one did you plug into, Daniel? Top or bottom?
Top.
Top, doesn't matter.
No.
No. Okay, so Daniel chose to plug into the top. I probably would have plugged into the bottom because it's all positive, but it's all good. Plug into top. And you're plugging in for x. 3x minus 2y equals 4. And then you solve it. There's where I saw a 6 in my head. So, if you want to get your puzzles out now, think we're on puzzle 3. And there's 5 eliminations to do, and that's what we're going to work on for the rest of class today. Now, some of them already have a 0 pair, so you just add and go, okay? Some of them you have to multiply through and kind of think about what you're doing. But again, I think 7 and 8, I don't know that you're going to see ones where you have to multiply 2 equations that often. They are trickier, but again, if you can do those, then you can do any of them. So let's get our puzzles out. Let's work on those.
We finished puzzle 1.
That I want you to do puzzle 3 right now. Puzzle 1 can be in tutorials.